Hello, welcome to another video. I'm doing some uh, BitTorrent hacking, I guess. So I think the last video I had, the test servers were not working at the point, which that has been resolved, and the tests are passing. What I might want to do is do this one. Yeah. Um, so this TCP flow will uh, pretty much show whatever pairs I'm connecting to. So I've got some stuff here. What do we want? So we can see here that we are receiving some like metadata stuff, which this one is meant to be sending it, and the next one is meant to be receiving it. So what I think I kind of want to do is perhaps send it first. Well, we'll keep that open. And then we can get down to the receiving part, because the receiving part, yeah, I've kind of started doing it. So we add another extended. We should probably do a something like this in a log. No, what do we do? We do a pair log. Um, so yeah, log receive, and this is the extended, and I guess we just say that, but I guess I want to kind of say um, what it is. So perhaps I want to do this handshake. Uh, so you can actually send, and here we can receive extended and uh, ID, and this will be a D, and we can just pass in that ID, and the rest can be printed. So, yeah, what I first want to do. So that stuff that I was kind of doing off screen while I was waiting for this to kind of work. But for now, let's just kind of send the data. So I kind of know what format I need to send it in. So first off, I want to like kind of, if we can't get the this get pairs, I wonder if that is what we want to do. So I have had a cheeky look at kind of what's coming up. You can just kind of peek. So yeah, you do need to kind of store some results at some point. But yeah, like we need to kind of do this request for the metadata, and that's kind of, yeah, we need to receive that. So we need to wait until we get this and then do the handshake if need be. But that kind of means that we might not have the pairs, but it suggests that we kind of do. Um, but perhaps not. No, because we're just downloading the whole thing, and I guess that means in this. Like, I kind of want this wherever get pairs to do so like if this doesn't have a um go to error and error we just return null, which so I guess this is meant to be doing something like this, and this is probably meant to be doing something like this. And because I'm kind of doing this, I kind of want to do something like this and just do that and do that, but maybe also um, check that first. And up here we can kind of just go ret equals false to start with, and it is a bool. This I kind of just want to just do return false, which yeah. And otherwise we do this. So torrent pairs kind of gets allocated, but that's kind of after you get a tracker response, which it's kind of interesting. So we do have the tracker. Yeah, I'm kind of thinking way ahead of myself. Whether you need to do like DHT type stuff. I think that's what it is. Next word, DHT distributed hash table. Um, yeah. It looks like what it is. Distributed hash table. But yeah, I don't need that because the magnet URLs for this test have the tracker in it. Other magnet URLs I was looking at do not. So I guess I want to perhaps uh, do like a tracker equals so this should equal to like this thing here, otherwise it will be null to start with. So yeah, I think if it is null, we should perhaps do a e log no tracker. Well, in fact, it's really unimplemented. Uh, the DHT extension, and that will be that, and it shouldn't ever hit. Cool. So let's stop sidetracking myself from that. So here we want to send a request, and the request is just going to be like a bunch of data. So I think here we have the handshake. So at this point here, the pair has some things. So what does it have? It has the reserved stuff. So if a certain reserved is set, we want to, that's in here, isn't it? Yeah, pieces, what is it? Ears, and shape, here. So this one here, it will get reserved. So we want to check whether the reserved, the correct one is done, and that will be whether it is this Bittorrent extension protocol. So maybe in here I want to do a define. Uh, Maybe I'll just call it test Bittorrent extension. Um, uh, and do something like that. So we will still give it like all the extensions, but we will still do that static assert. And here we probably want to see, this is tricky because I want to uh, kind of wrap this like in an if statement. So I guess I can't really do that static assert, which is a little annoying. Because I want to make sure that it's a legit. We could make it a cheeky bull, not cheeky bull. So if we go here, we can uh, make it a static align something like this. We can potentially make it that, and this will be u int uh, 8 t, and it will be of a certain size. So like um, our extensions is just num Bittorrent extensions. So do we do it like here, like that? And this will be uh, just a something like that. And then we can in here get rid of that. And we want to return something like that. And we can now get rid of like so if we see just extension like that, we can just replace it with extension without it. Cool. So we check it is in range, and so we want to get this, and we kind of want to um, end this whole thing with that. Um, Except we don't want to do an equal. So let's do something like this. So here we would probably just return that and that whole thing equals uh, well, not equals 0. So if that is the case, then that is the case. and then we can do something like that. And this, yeah, so we didn't like something there. Is it because of that? Um, I want this. Yes, we can't do a static assert if we do it like that. So I think I do want this to be keep fine. This whole thing is nah, let's go back like that and do that. Um, so we won't have stuff like that. And so I guess if we can't even do that, what I can do is just not even do the static assert, and we can just do something like that. And maybe we can like open it up with a thing. Um, so something like that, and then at the end we can just kind of wrap it so it's like one whole condition. Maybe I'll chuck that there just to make it a bit clearer. Maybe I'll do that and go there and do that. So that I think is kind of the condition I want. Right, so now if we do some things, that's kind of all right, but now we need to kind of do a test whether that has been done in the pair handshake. So if test what was it, Bittorrent extension, and this will be pair slash reserved, not request, reserved, and we want to check for BitTorrent extension protocol. Also, if that is the case, we want to do some things. So maybe here we can probably do like a log hand shaking extensions. Do that, and for now we won't actually do anything. Right, so this didn't exist, and that is because I put it not in a place that is handy. So where do we want to kind of store this? This is like a very raw response. So I guess maybe just even I'll chuck it here and work out where I want to have it later. Um, just to kind of see if it is doing it right. So now that doesn't kind of work. So maybe this does need to, well, you do exist. So maybe this needs to just be in like a more public section of the peers. Um, Something like that. And then maybe job.c and test. Test that one. We can also shove in there. Cool. Right. So did it say what I wanted it to say? Handshaking extension. Yeah, cool, it did. But we never actually did any of that handshake. So I guess what extensions do we support? So that is the gist I get from reading through the extension protocol document, which is um, reasonably uh, short. So we just need to send what we support, which for now will not be on this one. It will be here, and it kind of says what we need to do. Well, it doesn't actually. It kind of suggests it here. So we need to send a message payload. So I think we kind of have like a so we just do a peer message type. So we will have a peer message type type equals extension extended. I think it is what it is extended. Yeah. So we will create that type and the message length size the link service packet length. Now I wonder if C will kind of let me do this. So this is going to be one currently. No, it'll be 5. So that will be U it's 32T. So it's pretty much going to be that like the size of this plus the 1. Though I think from reading this, we read the packet length and then we read the type and then we take one off the thing. So the packet length does not really include itself. So it'll just be the 1 byte. And whatever we add to it. Right, so what we're going to do is we're going to have like a encoded value um, data. So I will just need to kind of reflect myself as you. So I'll just see if this it just unused. That's fine. So I just need to remind myself how the encoded stuff does kind of work. But we can first kind of just do a write full. So we're going to send it to the peer thing, and we'll send the packet length. And if that did not work, then we should potentially just I wish you could like break out enough. I mean, I could change it to like a while, but I guess this should just be return null and not actually do that. But maybe this should, and it's also not actually testing this. Um, so what we could do, we want to we could do like a cheeky thing like this. So like each time the thing uh if one fails, the whole thing will fail. And what would we send there? So this will just be type, and um, we don't actually send it like that. We need to do this right for a link, just because it's a bit weird. So if we manage to write both of those, we should probably write some data as well. So this will be like, uh, I might just do unimplemented, unimplemented, uh, right, been included dict to FD. Because the way that I did the mini coded library was a little strange. So I guess I should try and work out what's what and how I could potentially construct one. So I can kind of construct it by, I guess, just kind of Um, we would have a type, and from what I understand, the start and the end we don't need, because that's kind of where it was in memory, but we can just have the type, size, and data. So this will be the type, and say if it is a dictionary, we can just say type equals dict, and the size is whatever size it needs to be, which I think for a dict it doesn't really have to do anything. Um, so I mean we can see here the data will be there. The size uh, does get set to be a size. And we do add to the size. So the size is just like the length of the data, I guess. But the data is, yeah, kind of interesting. But then we have this like kind of janky print bin coded value, which will print it just to stand it out, I guess. So I guess I could change this to just be a D print and it will print to whatever file descriptor I tell it to, which is potentially what I'll do. Because why not? Um, so if we go down to there and maybe do this and uh, for backwards compatibility, I'll just do this FB. Um, so every printf, I guess, we need to change inside of here to be a dprintf. So I could probably do something like this, and then search for printf with a space, and we can, and then one of those, and then we would replace it with dprintf, one of those, and the file descriptor, then a comma, with a space. Yep, and that should do the printing that I want, and the rest is like, yeah. And so this we can probably just kind of return the print this, and send out file. Gosh. We probably just haven't included it, so yeah. It would be include unisted .h, I think, and uh, yeah, there we go. And then we just print in the value in config as well. So, the size is like the size in this dprim. So if it's bytes, it uses the size, and it prints it from data. Cool, good to know. If it is integer, the size is the number. If it's a list, the size appears not to be used. Cool. And a dictionary, I would assume, is the same and not used. Cool. So we could probably go back to I think it's all in job at the moment. And what do we want to look at down here? I want to go not to there. So we have this w equals I mean, I've got stuff like that, right? Cool. This is where I want it. So this is going to be height is a I think I might want just to close that and maybe open Bing code and I should set up so it goes to where I want. I want it to be a dict. And this will be a data is going to be like pointed to a encoded dict, which is going to be something like that. And like, I don't know, something like that. And I kind of want to see what this kind of looks like. So like if we do encoded value and this, what did it even take? No, I want, no, I just want to go to its thing. Um, cool. It takes a config and the value. So we will give it the value, which will need to be a pointer, and the config will be encoded uh, encoded print config. There you are, and that can just be like a default, I guess. See what that kind of prints out. And right, so we can't do that, but I mean the dictionary can just have nothing in it to start with, and we can go from there. Cool. So handshaking extensions, and it printed out a little thing. It printed it out twice, I guess. I suppose on both things. So maybe I'll get the print log. Now, have I actually just kind of made a thing like that? I don't think I have, but um, because this is um, just kind of testing, I won't bother checking for things, and I just want to kind of make sure that things are a-okay. Now the print being coded value, what does that allow me to have? We can have new line and no quotes. So maybe I'll give a new line equals true. It was like real janky, this thing I made. And it, it did a thing. No, take me back to this. Thanks. Right, so it did a thing. Uh, so I think this is roughly kind of what we do actually want to do. So maybe I can do something like this, and well, it will be something like this, and this will be yeah, file descriptor and do something like that. Now, what do we want in this bin coded dict? It just takes a next, which would be. I'm just going to kind of construct it like this. So it's going to take a next, which we can just explicitly set now. So the key is going to be gosh, a pointer to a bin coded value, which will have a type of bytes. So it will have a. I need. Maybe I want it split like this. No, I like this. And at bin code just to see kind of what's what. Um, right, so what do we want for this? We want this size to be ln of n, I guess, and the data is just going to be m. Um, right, and we can probably do that. And then we probably want a value to be in our M. Well, so this will contain and this is just going to have another dictionary. Gosh, this is encoded value, and this is going to have a type equals um, dict, I guess, and I don't know, something like that, and maybe data can be started off, being encoded dict, and this will just be 0 for now. Wait, that's not what I wanted. That is. So I guess it does this kind of thing. It's missing some things. So from this, we need to come down into that. So I'll do it again just to kind of see what it did. It has kind of printed that M, but with a new line. So I also wonder what's happened up here because we should have seen some stuff. I would imagine. Um, doesn't look like we actually have. Because we can just set that to be nothing. Um, Something like that. And I would expect us to be like sending that. Sending it. Why are we not sending it? Why is this print locking not kind of working? I wonder if I just want to do something like that just to kind of make that get over. Yeah, so that's kind of what we're looking at. I think that's one full thing. So now we kind of want to add stuff into here. Except I don't want it to print like this. I want it to print like the bin. I want it to be re-encoded, I guess. Um, which I wonder whether I just kind of make up myself. But I could kind of add a new function to this, I guess. So we decode it, we kind of want to encode it and give back a like a little um char char. So the I think this was not needed, so I might, in fact, let's make use of Git. So we just want to kind of get rid of uh, that and that and that, and that didn't do what I wanted. Is that what I want? Yeah, sure. Tell me what. I think I have successfully been. Cool. But let's Cool. So this does not have the the old print stuff is kind of still working. Cool. So I guess in that case, I need to let's make a new kind so this is going to return a string of uint uint 8 uh, 8 t. It's going to return that, and we're going to encode then coded then coded uh, value, and this is going to take the encoded value and it's going to take that, and we will write out what is needed. So I guess that's what it was. So we will probably have a unit 8 type and ret, and we will start off with that being null, and at the end we will return it. And at some point in the middle, hopefully, we will allocate some space for it. I wonder if this is the way I want to do it, or whether. Because I need to kind of go through all the values and work out what um, the start and end they should be. Yes, because the problem is that on the first key, I know it's a dictionary, but I don't know how long, how big it will be. So I kind of have to do 2 passes, which seems a little wasteful. Like I have to go through each value and kind of well, yeah, actually that's kind of what I want to do. I want to go through each value and allocate like a bunch of space. It's gross as to work out how long each of those should take. Um, at which point we would free the thing that we need to kind of add in. So yeah, maybe I'll do something like this. So we're going to switch on the value. We should probably test if value equals null. We can just return null. So otherwise we can switch on value slash type. And so I guess this is going to have a case unknown bytes integer list dict. So if we have an unknown, we can just return null. There's like nothing we can really do. If we have bytes, we can do some stuff. If we have int, if we have a case dict, and there was a list before that. So these are the things that we want to do. So if it is bytes, what we want to do is we want to return almost like AES printf. Do I have that thing there? No. Is it just S print F? No, it was AS. So we kind of want to allocate. Oh yeah, so we weird way to do it. Um, yeah, cool. So that's kind of what we want. So we would have. I think each of these I kind of want to have in a thing, and we're going to have a chart star. Uh, uh, well, we kind of have. Um, Come on, out there and something like that. So we wanted a pointer to a pointer, then the format, then what? So we kind of have that in ret, and the format we want to do is something like the we're going to have a size. Um, Let me remind myself on bin code. Yes, that is what it is. Yep, sorry. Oh my god, I clicked on the wrong thing. Sorry. Uh, right, so if it is a byte, we just have the length uh, colon by the just the contents. Um, well, no, I'm doing this like a bit weirdly because it might not be ASCII. Right. Is that kind of does not deal with the encoding. Yeah, cool. So what we can do is we can just go ret equals to malloc, and this is going to be uh, the value. And we should probably have a size allocated there. Um, uh, if value size equals 0, then probably return. Well, no, we do some stuff. So if rec equals null, we probably return uh, null. Otherwise, we would uh, s print. No, like because we need to know how many 10-digit characters it would fit in this value size. Because this is going to be value size plus 1 for the colon, and then plus uh, so maybe we can do uh, size str, and we can then go as print f. I mean, this is what I want. And we give it a pointer to that size str, and we then print out the number with the colon. And we do value size. And so here we can just do plus SDR then size str. And perhaps we should keep this as null, and uh, if size str equally null here, we should probably return null. Otherwise, we do this, and I think I want to something like that. I didn't quite take what I wanted. We keep that. Otherwise, we have what we want, and then we can just do mem copy. So we want to mem copy to ret plus str len size. Um, from that point, we want to copy from value slash data, and we want to copy value size of that, and then we should probably break and not fall through. And let's do something like that. Cool. So that's how we would do bytes. The int I is reasonably easy. We can probably uh, just do something like this. So we do like an AES printf, and we just give it the ret, and we are printing what I, then the number, and then E, and adjust that, and we give it the value size, and that is that. And the list, we would do something like, what would we do for the list? It's list then like everyone joined in together. So here we need like quite a bit of space. So when you work out the total length of all of our things. But what I think I'll do is kind of a bit gross. So we could either reallocate lots, or we could just kind of allocate maybe twice, I think. Yeah. So we would have like a event 8 type, and it will be a double pointer. And this will be an array of things in our list. And so we'll start off with enough space, so we could potentially even do a calloc, and we want to remind ourselves, so it's the number of members, which I believe is the list size, and here we will just do a size of, and it will just be a size of a pointer to a byte array. And so now we can do a for, and like our list. Remind me how the list, well, when we print it, what do we do? It's a linked list. Cool. So we don't actually know the size, but do we store the size when we I hate I hate memory things. Well, I mean, like you kind of have to keep in mind what's what. Um, so yeah, we basically don't have a thing. So what we can do is literally just keep on allocating space as need be. Um, so I would hope that there's like uh well, I mean, we can walk it once. and just kind of add to the end of another list while also keeping a track of the total size. But then we would also kind of need, like potentially, I just need this link list to be a bit more like visible. So, for example, I could probably do his def lists. I mean, I just want a so we need a struct there, and then we would call this whole thing a list, and all it really has is a struct list next, and I guess a size t. Well, we don't really need a size t. We would probably just have a void star data. But I kind of want to make a unit 8 type there of the data. So we are kind of just building up a linked list type thing in the middle. So what would we have there? We would start off. Uh, so we would have a. I don't know why I called this linked list down the bottom. We can just call this a list as well. Though is a list a kind of overloaded thing. Um, we have a bin coded list. I think that's kind of all right. So we would create a list, and we can just call it a L, and well, this is going to be our kid, and this can be like that, and we can have a pointer to a list, which will just be at head, I guess. Um, and it should be null to start with. So then we want to do like a little while loop, and we want to get this other list coming out. So we'll have the bin code list, and then we'll at some point at the end we will L equals L next, something like that. And at which point, I guess we need to kind of create a new list node. It's kind of gross. We're just creating a bunch of memory. Um, like you just have to have some memory somewhere. Um, actually, no, I'm being foolish. If we just stream this rather than yeah, I think we want to stream this. So I think this we kind of want maybe to be like bool maybe, and we're gonna print to a file descriptor, and so this uh, I mean everything really. So if we returning null, we can return false instead. And the rest is we want to deprintf and we'll just give it FD, and then we kind of just want to write to FD the value data and value size, something like that. And who cares about error checking? Maybe I do. So if we couldn't do that, we can return false. Otherwise, it will fall through. And maybe this less than 0 equal to 0. We can probably return false there as well. Right, so that's bytes, and then here it just makes it a lot easier. The printf, and here we would just do the file descriptor. Here we would do the printf, printf with the file descriptor, and we'll start it off with a list. Then we will do some stuff, and then we will just do the printf, the file descriptor, except we're not doing that. We'll do encode, encode value with the same file descriptor and the list value, something like that, and give that a thing, and then we'll do the printf, printf file descriptor, and we'll end that list. And I can see that the bit will be very similar. It will just be a D instead, and here we probably can do bin coded dict, and same thing there. And so we would do the key and then the value, that's what I'm kind of thinking. So D content, so key followed by the value, easy. Now this, it should be lexicographical, so that's something that you should probably do some checking for, if that doesn't work. So perhaps I can do stuff like this, equal to 0, and then return false, and if not that, then we can also return a false, and we can probably just steal this and replace that with E, then do that down there, then up here, and find find the E and replace it with a D. And then here we can probably do something like, if not either of these, then we could probably do return false. And I thought I had that in my full stop, but didn't. Right, so this would need to be a D and a D. So here we probably want to fix me. These should be in lexicographical order. Not something I check. So I guess I could check that. So maybe something like if D dash next and strcmp of the key with d slash next key. If that is less than zero, which means no, if we are greater than zero, that means that's something like wrong. Uh, Potentially, error message could be nice here, because this should be unreachable. In fact, being coded dictionaries could be in electrographical order, something like that, and that does that. Now the list shouldn't matter, and the rest do that. So now we have a little that we don't need a list anymore, I don't think. And so we can probably go to a job and we just want to encode it onto that string. So we have a print encode. There we are. We can see what it is. Otherwise, we can just go back to here and encode encode string from the file descriptor um, to it, and something like that. But we should probably finish filling it out first. So I guess if I run this, it doesn't work, of course. No, uh, that just means I need to do this and go back there and do that. Right, what does this one? This kind of annoying. It, I don't know, cursed. Right, I'm happy with that. Yes. I don't need to do anything there. What don't I do in here? Int. I guess it's an integer. What about here? Right. So this it's assuming that the key is uh, a string. Um, so we should probably do something like uh, maybe if we don't have a key or the key type not equal to bytes, because the gist I'm getting is all keys must be byte strings. So this is unreachable encoded dictionary keys must be bytes. Um, and we probably want a similar check if the next and something like that. Um, and then we can safely just compare these, but maybe with a size. So not CMP. Yeah, so CMP with a size of N. So the size is going to be, well, can I just do the SDRCMP, SDRCMP? If there are null bytes, then whatevs. Right, we don't have an unreachable. Maybe we can just do a cheeky include to. Uh, I mean, I don't really like it because, well, we can probably do define unreachable to be printf std air and it'll be a string followed by a number followed by un followed by a string and then unreachable and something like that. And also then pass in whatever we just got, which we have to add, and finally add that new line. And here we can do this, and so that means this will need to take in a format and a dot, something like that. Right. Doesn't like that because we probably also need to give it a file, a line, and also something like that. It's really annoying. It doesn't like take its errors first. I mean, I said warns errors. So return true if we get to the end there. There's still some unreachable redefined. I think right. So the unreachable, I guess. Um, unreach. This I need to uh, add in a little thing like that. Cool. So dictionary keys must be bytes. So it is kind of failing at some point. And it is doing some warning of some things, which I should probably take heed of. Probably just those two. Cool. So now I just need to get my dictionary into order. So my key is bytes. But it reckons it's not. Interesting. So, yeah, sure. So here, what do we have? That was on allow reachable, was it? So it reckons. Oh, we might just not have a key. So that is entirely correct, because we potentially could do something like that. It doesn't like that. I don't know where this came from. Oh, I deleted a Malik or something. So I guess this message should be a Malik of I guess packet length, and then it'll read a bunch of stuff into it. And this, I guess, would need to be a unit eight T, and we can just cut that um, to that. Cool. That's just unused. Cool. So now, what does this kind of show when we send a packet? So I would expect that we send uh, something. I don't know. It seems like we're not. Um, I think I can do something like this. Do all of that, and then if that happens, then we can pair log extended and shake failed, I guess, and then we can just return. Maybe a return null is needed. Maybe just check the return type. So where are we failing there? It reckons we've sent it. Um, all right, so what if we don't have that line there? Yeah, so we do send some stuff here that just wasn't showing up before because I was aborting pretty much. So what do we want in our dictionary? We should probably add maybe just the stuff at once. Um, so it reckons we just need to have the metadata and our M. Now, we need to remember what the M was, what the number was. Otherwise, we may not understand messages coming in. So I guess here we want to, I don't know, this is like curse type stuff. So this is going to be being coded that I kind of want to make a thing define so being coded dict, and it's going to take a key value and it is just going to give me a being coded value, and that value is going to have in it type equals dict, and it's going to have data equals, and this is going to be pointed to being coded value, being coded dict, sorry. And this is going to have a like I guess a nothing. I wonder if this should only be returning the dictionary part. And we would just have the key. I don't know. I think I'll stick with the cursed. Right. So in this, we would have a next equal null. Um, So we would have nothing more in this. That kind of makes sense. Now the key is going to be an encoded value. I mean, this we could probably do a define of encoded bytes of this thing is just going to be an encoded value. And it's going to have dot type equals bytes, not type, bytes, gosh, and dot size equals strlen of whatever it was, and the data is just going to be whatever it was. And we can do something like that, and that would kind of make this a little easier. And then we can go being coded bytes on M, um, and that would kind of just make that a little easier. Then coded bytes, and this is going to be what underscore meta data. Um, and I don't know, can be one. Nah, we should probably get data. Have a extension. Yeah, like maybe we'd have a type if enum and we're updating it, and this is going to be extended message type, something like that, and we make it up. So metadata can just be, it has to be one maybe. So maybe unknown can be the first one, then metadata. And maybe we would have a num types at the end there, and we should probably do a static assert of getting a for private number. Uh, extensions. So this maybe is just one. And maybe we can just go metadata. And the metadata extension is defined in like BIP9. Uh, 9 meta data and nothing else. No others. And then we can do some stuff there. So this can be our metadata. I wonder if it will let me do stuff there. So we don't want that. We do need to have a value, and this can be so metadata is it's going to be a int. So what's that going to be? It's going to be a type equals integer, and its size is going to be metadata, something like that. So I wonder whether this whole thing can kind of get into a thing. So maybe this can be define bin code and maybe any tree, and this can be a key and a value. And what is this going to give me? It's going to give me a encoded bit. And the problem is that the next and the we just won't set the next, and so this can be the key equals the k and the value equals the v, and we would just have to update that to be what we want. Yes. So this can be encoded bit entry, and this can be UT meta data. Oh no, it's not going to be that. It's actually going to be the where do we go? We want that one. Going to be that is going to be our key, and then the metadata. Gosh, I got some deja vu. It's going to be that. Problem is, we kind of want a dot dot dot, and like we have if we have stuff, then we want to it kind of add in the next. Well, maybe I can kind of just add in the next. Dot next equals next, and we can call that in there, and we can just say this is the last entry. Maybe that's kind of how I'll do this. Cool. And so this whole thing can probably just become data and this can be so we do need a printer there. So this is going to be the encoded entry of being encoded bytes, which is n, and it's going to go. Its value is going to be this whole thing here up to there. So maybe we can kind of do that. And at the end there, we can just go null. And that's going to end off that entry. So maybe I want something like that. What does this give me? We don't know. Unknown. Unknown. Extension. Right. Num. Extensions. We got that. Encoded. Right. So past 5. Why did we pass at 5? Is that because this is like um all right, maybe let's go away from we can do that and maybe eat your and this can be I who something like that and we're cool just to get rid of a few things unknown extent and shown and extensions. Cool, that static assertion failed. We have 2, is that the case? So that means that we that's what we've done. We probably want to do that and like maybe go here and do something like that. Cool. Actually, we can go here and handshake. Handshake will be our first one. So bit O 10 handshake and that one. So what was it, BIP 10 extension, but it kind of talks about the handshake, which that's all good for me. Cool. And that's not even where it will be done, but it's kind of in this little bit. And maybe also down in this little bit. And maybe these two things belong in bin code. I didn't want to do something I did there, but that's all right. Maybe we can chuck these bad boys. I don't know. Yeah, I thought that might be the case. Right. What did I make there? So it was a type def. We don't need that. It wasn't a type def. It was a hash define. And it's going to be bin coded bytes, and it was taking a string and it was giving us a bin coded value, and it was going to have a size equals to str len of whatever our string was, type equals bytes, and then the data equals whatever it was. So this size we probably need to do that. Int e integer, then I, we can uh, integer, and the size will just be the integer that we pass it. Cool. So we got that in there. Cool. So we're like printing out what we kind of have. So what I'm wondering is if we kind of get rid of that. This is kind of a little ugly, but I guess like at this point here, the next would just become like another nest of this. So, for example, like if I wanted to do this hex, I could probably just do something like this, except this is under except this is there, and this is like there. Um, Something like that. Except I would need to make sure that whatever is in here is lexicographically right. But for now, I think I will not bother printing shit and only kind of write out the extension. So here we can see that we have done some things, and we received an extended handshake, and I think we haven't done anything with it. But yeah, I wonder if this is like all we kind of need. So if I just do a test, no, that doesn't do it. So this whole thing has kind of been mm, it's been done like outside of the no, we're still open. Um, we we want to kind of add in this magnet handshake, and up here this does like a bunch of stuff. So it it works out stuff. Then it finds some pairs. Then it goes with a random pair. And here, where we do the handshake, we want to um, print out the thing that it does. But the problem is that this handshake, we're not sending the stuff that I just did outside of that, which is a little frustrating because the handshake, it should potentially happen inside of there, but we might not get the response straight away. So for example, we actually received the bit field as our first response. And the extended is kind of like an afterthought. Even though we do say that we support it, but yeah, so where are we there? So that's like after we've received it back, which I guess what I kind of want to see is whether we get that other kind of message. So we haven't. We need to request it. Anyhow, this has been a bunch of stuff, and I want to just see whether this is kind of enough to pass the test if we do this gross thing here. Where was it? Pieces, handshake. So if we did like a handshake, set just like where we are. No, that's like download from PAL. So we do like a few things: download from file and also download piece from file. What about just cat name? We do a handshake. This magnet handshake. I think I just want to kind of add it in here after we do this handshake. We can just print out our thing. So we can probably do something like that, and the response is gosh, it's gonna be like response uh, plus some offset. Plus 2 by the looks. Yeah, like where does extension size come into play in other places? It does not. Yeah, pieces. Cool. We'll save whatever we get there. Pieces. So when we do this, what about an hands? This is just where we do the handshake, and extensions is so potentially it should happen here that we send in the extra stuff that we want as the first handshake, and like why not? Because this is where we actually set the fact that we do it. So maybe in app main, we want to do this test whole thing here, and in this, we want to do that inside of the app here. Handshake. We want to do that inside of here. So after we receive that handshake, we probably just want to do this. And the response we can quite safely say is this reserved. And that's what we do. And so if they support that extension, then we do that. And the num extensions is set somewhere. I don't know. We should probably set num extensions here. I guess in the app job num extensions, something like this e app here, and maybe just plonk it in like here. Um, what's that gonna say? I want to go to here. Right, so we don't have this, but we can do like an elog, elog. Um, I mean, the peer extension could be kind of useful because we do know the host and the port. Um, but that's all good. Um, right, so e log there and maybe there as well. E log there. So I guess if this fails, we probably want to do this go to error bit, and the error is the thing. So go to error. That is what happens if the handshake fails, and cool. We don't know about this. That is because we have that defined over here, message type. So this whole thing can probably get edited out into here, and we can just lob that down. I don't know, like here. It does not like something there. Right, so now we don't know about this, but we do know about stock and stock and stock. Cool. Redefinition of stuff because we have it in here. That's all right. We can just kind of get rid of that one, and everything all works. And it looks like we're sending in a bunch of stuff, potentially multiple times. Yeah, so now we're doing it multiple times. So in our job, we want to not do that. Doesn't hurt if we do, but I feel like we do not need to. And so now if we do that, it should just do it the once. Um, and I think if we did like a maybe a make PRG and do that. So this is kind of the code that it wants, and we have sent the thing, have we? I'm not sure we did. But it says that we did, but we haven't like sent stuff off. So I wonder whether we did. I wonder why. So what we can do is literally just go test, and it will test whatever my current code is and see what happens. So it did something up here. That was this compilation. So yeah, it looks like we didn't quite get what we want. And I think you can do the Codecrafters, and if we set this old boy to true, uh, we can like get a bunch of logs. But I think for this is like I don't know, it's doing something. I just need to work out the network side of things, like why it hasn't sent, or it's like maybe uh yeah, cool. View logs. Cool. Was this with it with debug on? I feel like yeah, debug true. Um right, so this is what it's doing. Yeah, it has not received it. So I feel like this is just a slow debugging process on why not? Because it looks like it's sending it. But yeah, that one. But now, thank you very much for watching, and I hope you enjoy your day.